I'm going to tell you about a project we have. This is called The Void. As I mentioned earlier, so I'm with a company called Prowler Cloud Security. Not going to talk about that. So The Void, the Verica Open Incident Database makes public software-related incident reports available to everybody for a reason. Let me tell you a little bit about why this came to be. So I love failure stories, right? And software failure stories. Organizational ones, like why most SRE programs don't work out organizationally, and technical ones. For example, some of my favorites are when people make a technical decision to make a system more reliable, and that decision ends up taking the service down. That just tickles my funny bone. So like and as I mentioned earlier, I had the privilege of talking to a lot of different big infrastructure companies. So I was very excited to collect these stories, and I had an interest in that. And I started a startup called Verica that had a solution for Kubernetes and Kafka to help make them more reliable. And so as we were doing product development for that, I asked a researcher, Courtney Nash. Her title is Incident Librarian, which I think is the coolest title in the world. I asked her, help me figure out what are the ways that Kubernetes and Kafka fail so that we can, educate people about those on their own infrastructure, and then they're presumably be less likely to repeat those mistakes. So she started kind of just gathering examples from the public of notable failures that mention Kubernetes or Kafka. And we put that online in a database so that we can manage it. And then we started adding other stuff to it because, there are other great failures, so why not? And then other people started asking us if they could use that data or use that database. And we said, sure, why not? Research, this is fun. And so we ended up with what I think is the only attempt at a holistic database of public outage data. So if you go to the database, this is what it looks like. And there's some tags, but generally you can just do a keyword search on like AWS, US East 1, and get a list of failures from that. So what kind of info populates this? The purpose is we all have incidents. So of course, we're looking for similar problems or rhyming to the pattern of outages versus keeping them in the silo, which is essentially what we had prior to an effort like this, where there would be some press release about an outage, but really AWS wouldn't talk to Google, even if they had similar outages, they wouldn't really connect the dots. Yeah. So here's what's in it. Many thousands of reports going back to 2008. We decided not to go back from that. Some of them are simply social media posts, status pages, blog posts, conference talks, news articles, basically any form of media that we can reference that talks about an outage. Our favorites really are comprehensive retros or postmortems, but those tend to be more rare. The metadata that we look at, again, this is not necessarily complete data for all of these, but these are the examples of the metadata that we like to pull out. Obviously, the organization or application. When do they talk about it? Is it firsthand or is it reported by like end users? If they have some mention of duration, that's always fun to talk about. The technologies that are involved are very interesting to me. And then any way that they try to quantify the impact, the severity, how they handled it, this is all great stuff, right? So we just try to get all of that together so that, we can be, the world experts in how things fail, or, we're expert failures. Yeah. So there is a historical precedent for this that kind of inspired some of our thinking in terms of resilience engineering. And that's, it actually goes back to 3 Mile Island and nuclear disasters. But more recently, the airline industry in the 90s had a bunch of safety issues. maybe coming back.
Yeah.
What's old is new again. But in the 90s in particular, what we found was that the airlines were keeping their own incidents to themselves. And so somewhere in the mid to late 90s, along with some regulatory pressure in the US, they set up programs to, try to require airlines to share that data. And then once, pilots from Delta could talk to pilots from United about like, oh yeah, you had this problem with this plane, I did too. They had much richer context and plane safety. Even with the Boeing issues that are going on now, plane safety in general is far improved from where it was even 30 years ago. So our hope is that by sharing information about outages, again, we can enrich everybody and improve the space for everyone who's running a technical system. Any questions about what the database is or what we're trying to do there? Does that make sense? Okay. Roll my sleeves because I'm hoping I can make some people uncomfortable here. So once we had all that data, we're like, cool, let's do some original research. And there's a bunch of assumptions in tech in particular about the kinds of things that make a system more reliable or more robust. And a lot of us working on this project have a background in resilience engineering, which has a lot of opposing ideas of what makes systems more reliable and more robust. And so we want to see basically, do we have the numbers to prove which of those is right? Turns out we do. So I'm gonna pick on these three. In the interest of time, maybe just the first two. So MTTR, I hope all four of the providers have said something about MTTR, and I won't say what I hope they said about it, but I hope they mentioned it somewhere. And I'll go a step further and say this: it's not a observability company, or I don't think they would categorize themselves that way. But PagerDuty, their marketing slogan is that they help reduce MTTR. And without knowing anything about what they do, I know a lot about what they do, but even if I didn't know anything about what they do, I can say they're lying. In fact, I asked them for their data, and they said, we actually don't have that data. Somehow this came about in marketing, and we really believe it's true, but we don't have any data that can back that up. So we do have a lot of data on time to recover, in particular, or time to remediate, across a bunch of different companies, and we plotted that data. And does anybody here have a background in statistics? Really? Nobody? No math nerds here? Okay, yeah, well, I'll take it. Okay, so this is great. What I have here cycling through an animated GIF are different companies. And we've plotted their time to recovery, time to remediate, their TR. And you'll notice there's a shape to that. And over here is a mean distribution. Now, if you're going to talk about mean of anything, your distribution has to look like this.
Yeah.
None of these look like that. So without knowing anything about the problem you're trying to solve, I can say you're using the wrong statistic. Which is unfortunate because it makes a lot of sense. You think if I reduce the mean time to remediate, then the service must be better, right? No. Mathematically, we know that's wrong. And using median instead of mean doesn't help. But in case you doubt statistics, well, we proved it empirically as well. We ran some Monte Carlo simulations showing that even in cases where we artificially shorten a segment of the incident remediation time by, say, 10%, we can still show that for almost a third of those, the mean increases. So it's lying to you. It's telling you that the service got worse when we artificially made it get better. So that's one way that MTTR is wrong. Okay, now I'm going to dig into more ways that it's wrong. Who here pays attention to MTTR? Is anyone bold enough to? Okay, maybe. So here's another direction. When some people measure MTTR, the assumption is that tracks with user experience or the quality of the site. And there's another assumption in there, which is that longer incidents are worse. Turns out that also is not true, and we have the data to prove it. So a lot of times, the most severe incidents are the shortest, but roughly, they just don't track. So again, for that reason, even if you did have a good statistic, but you don't, it still wouldn't matter. You're still doing bad math. And yeah, John kind of underlines this, but it's roughly like saying, how well are firefighters handling forest fires? Oh, well, let's count the forest fires and measure how long they last, and that's going to tell us something about the state of fire control in a country. That says nothing about underlying conditions or the health of the landscape or commercial impact or any of those things. It's easier for us to point at something like that and say, well, yes, obviously those things have nothing to do with each other. So fatal flaws for MTTR, any one of these should be a nail in the coffin, but our industry still generally accepts MTTR, so I think we need many nails in this coffin. It's a provably wrong statistic. The second one is a statistically insignificant data sample. So in order for you to have enough data to say something statistically significant, such as we've reduced MTTR, it turns out you need more outage data than Google has.
Right.
If you have more outages than Google,
Looking for another.
you probably have other issues than how you're tracking data. So again, even if you had the right statistic, you don't have enough data points to say anything meaningful about whether you've moved the needle in a good direction or a bad direction. The duration doesn't correlate with severity. Measurement errors. Nobody measures outages the same. And my favorite example of this are incidents that have a negative duration. Could you have a negative duration? Well, turns out sometimes something goes wrong and somebody else does something and it makes the wrong thing stop happening. And then a few days later, people find out about it. So your remediation was negative. You resolved it before you even knew it was happening. Quite common, actually, in large systems. So, you can't measure it even if you thought you could. And then, it should be the final one. Any of those should be fatal to MTTR. But the final one is, so what? Even if that statistic worked for you, what would you do with it? It's not actionable, right? Like as a CEO, believe me, I understand the comfort of being able to say, like, show me the numbers, just tell me if it's improving or not. I would love to have KPI that do that. But even if MTTR somehow magically did measure the availability of my system, what would I do with that information? MTTR got worse. Okay, so do what? I go down and yell at people, or, so it can't tell you how reliable your systems are. can't tell you how agile or effective your organization is. It can't tell you if you're getting better at incidents, responding to incidents. It can't tell you if they're going to be longer or shorter, or the severity, how bad any incident is. So it doesn't tell you anything, so you can't do anything with that information, even if it was information, and it's not. It's just noise. It's just a distraction. Sorry, we have this expression, beating the dead horse. Have I belabored the point enough? So if not MTTR, then what do we do? Incident analysis. So healthier companies that do MTTR, they see it's getting better or worse. What do? Well, they go look at their incidents to figure out, to understand at a deeper level what's going on when those incidents happen. You could just skip the noise and the circus and just go straight to doing that anyway. Now, there's a lot of models for how you would do that, but they all, the ones that I'd advocate for all come back to these systems are sociotechnical. If you're ignoring the human element, then you're missing out on the most important data. So you want to collect sociotechnical data. And you can quantify it later if you want, but really this is qualitative data, which is something that engineers are less comfortable with, which might be the reason why we keep reverting to metrics and quantitative data to try to solve this. But then you look at things like how many people were involved, the cost of coordinating an incident when one happens, who participates, who reads about it, who tries to understand, why, and then near misses. What's happening when your system is up, but almost not up? Because those are the kinds of things that usually don't get attention of management. Because why would you tell your boss, like, oh yeah, we were almost down, but that from a learning perspective, that's probably the most important thing that you could talk about. And before I get like, well, we could never do that at my company, like we're too big or old or established in our ways. This is from IBM. So David Lee from IBM introduced this program, and here we just have a model showing like, okay, based on the impact of the incident, so we're not looking at MTTR here, we've got a process in place, an agreement for how we're going to learn about that incident based on how big it was. So for example, if it's really big, then we'll bring in external consultants and we'll do all these things and bring all these people together to really understand what went wrong. And then it becomes a great learning exercise. So that's kind of the cutting edge of what somebody with a very large budget could put into incident learning. And he's had a ton of great outcomes from that. So just, a ton of people are involved in that process now. So again, best source of information are the near misses. The reason why is generally from a resilience engineering point of view, what we would say is what some of us would say is the purpose of talking about incidents is to learn from them, and the way to facilitate that is to highlight knowledge gaps, right? So near misses happen all the time, so there's more data. So it's a great way to get everybody in the room and say, okay, you describe what happened from your point of view, and you do. And then you describe what happened from your point of view, you do. Okay, and then, with a little bit of facilitation, what you can get is like, oh, well, actually, I just heard that the system operates this way. I had no idea. Like, I thought it operated this way. And then a third person goes, oh, no, actually, I have knowledge from, my historical context that actually the application or the system operates this way. And those moments are where you're providing alignment, where people are actually learning things that will make the system more reliable in the future. That's the best way that we know of to improve. And it has nothing to do with looking at a KPI or a metric. He says that in an observability tech tool talk. So yeah, near misses are successes. We want to study those. And I'll hit one more hot topic, How many people here have a root cause process? Okay. So let me just start by ruffling some feathers. If you are doing root cause analysis, at best, you're wasting your time. I mean that passionately. The ultimate reason for that is because they're constructed. It's a type of narrative that was actually invented with scientific method, 100 years ago, scientific management and Taylorism. And the purpose was, for insurance purposes, to place blame at the lowest rung of the ladder. That's what it was designed to do. That's what it still does. We still run RCAs this way, but we feel a lot more enlightened about it. But in truth, it results in the same outcome. So, for example, big outage of one of the big cloud providers about 3 years ago now. That happened because a configuration file was uploaded to a system that managed deployments for a big chunk of this cloud provider, and that misconfigured configuration caused the system that does deployments to, let's just say it crashed, right? And so to restore that system that handled the deployment of all of their cloud stuff, they needed to redeploy the database that had the configuration data. But they couldn't redeploy the database because the system that deployed stuff was what crashed, right? So you can see they had a lot of problems here, right? And so they were down for enough time that it made newspapers. And then afterwards, okay, let's have an RCA. Let's make sure this never happens again. And they find out that it's, one engineer committed one line of code, right? So from an RCA perspective, this is perfect. We know exactly which line of code was the root cause of this incident. Okay, so that's one way that you could read that narrative. Had that engineer been peer-reviewed better or drank more coffee that morning or done a better job, then we would have avoided this outage. There's another way to tell that story, which is the team that built the tool that parsed the configuration data didn't handle exceptions very well, right? And their boss, engineering manager, didn't keep on his team to update the documentation so that other people using the system wouldn't make that kind of mistake in the first place. And his boss, the director of the team for the tool that deployed stuff, hadn't advocated for test environments for the CI/CD pipeline like he had advocated for test environments for all of the application stuff that they had done. And the VP hadn't allocated money or emphasized enough that the test stuff was important to make that investment. And the CTO hadn't even had as one of their main goals that year to invest in this sort of thing so that the organization was aligned on the importance of uptime and reliability. Now, what I've done is just change the narrative. But you blame the guy's one line, it was a guy, the guy's one line of code or the CTO, which one is going to change the reliability of the system in the future? Don't make mistakes anymore to the engineer does nothing. You've wasted time. He didn't want to make a mistake in the first place. The CTO going, you know what? Reliability is a really huge problem and we got to change how we prioritize our investments to make sure that the cloud stays up more. That's going to move a lot of stuff and make the system a lot more reliable. So root cause analysis, it was a waste of time. It achieved nothing. The other thing, much harder to do, right? Confronting an organization with their priorities and resource allotment, much harder to do. That's the way that you make a system more reliable. And again, because we've got the void data, we've got data to show that organizations that choose that way of analyzing and interpreting events tend to be more reliable in general and have better cultures of reliability. So roughly, and there's many models to implement this. I'm not advocating a specific model, but you treat incidents as opportunities to learn, in-depth analysis, qualitative, over shallow metrics. The MTTR doesn't tell you the severity, doesn't tell you how customers viewed things. Involving people in the process and treating them as the thing that will help make your system more reliable, not automation, not treating them like the problem. Oh, you need more training. That's a common, when we hear that, that's like a red flag for a quick opt-out solution, or a sign that that an organization isn't ready to actually improve their reliability. And then study what goes right as well as what goes wrong. Over-indexing on just the outages and the bad times that customers have tends to leave a lot of great data on the table. So there are guides and different models, again, for analyzing incidents. We would love if people submit to the Void. Obviously, although we do our own, we're constantly updating the database with our own stuff. And then there is a way to actually join as a participant. So the place where we are now, companies like IBM have come to us and said, okay, two things. One, can you help us spread a more enlightened culture around incident analysis and incident response? And we said, well, we're not really consultants, but how about this? We'll get together a community of practice so that you can have peers, and we'll discuss incidents on like a monthly basis, and we'll do custom research and things like that. So then we can have roundtables of people from Bloomberg and IBM and other companies, sitting around going like, yeah, I faced this problem. I tried X, Y, Z. X and Y didn't work, but Z did. And then the other companies can go, oh, yeah, IBM tried this thing and it worked for them. And it's not, hey, boss, I saw a conference talk or I read a blog post. It's, no, I talked to the guy at IBM who did it. And that tends to be an easier avenue to getting buy-in for making some of these changes for improving resilience engineering or a reliability program. So we host that, we facilitate that. And then, as I said, we do custom research. So with our data and seeing data that customers will share with us, we're able to create anonymized reports that help us do better research on things like MTTR, root cause analysis, the impact of automation, and of course the hot topic now for everybody, ROI of Gen AI, let's say. Yeah.